All right, so now what I'm going to do in this video is look at a few examples from the More on Rational Expressions and Equation worksheet. All right, the first question I want to look at is number 1. It gives you a rational expression, and if you didn't read the directions, you might think it says to, or it would mean to just simplify this. So you might jump right in and factor the top and bottom and then cancel out a common factor. But the real job is to find where it is undefined. Okay? So the issue really is that the denominator can't be 0 because division by 0 is undefined. So what you really do is you take the denominator and you find out, well, what causes it to be 0? Doesn't matter what's on top, just the denominator matters. This happens to be quadratic, so I'd have to go through the factoring. And x minus 5 times x minus 9 is how it would factor. So I'm going to set those equal to 0. And I'm going to get either x is 5 or x is 9. And what I found were these are the two numbers that would make the denominator 0. So x can't be 5 and x can't be 9. Okay, so that's the first question. All right, the other problems I did during my online meeting, we looked at a question from 2 through 7. These are ones where you're simplifying, you're multiplying, or you're dividing, okay? So the idea there is going to be to make sure if it's dividing that you change to multiplication by keeping, changing, and flipping. And then you just need to remember to factor first, then cancel common factors. Okay, so let me show you what I mean. I'm just going to do one of the problems. I'm going to look at number 7. So on number 7, we have several trinomials. All right, now this particular problem starts out as a division problem. Okay, so the first thing you're going to do is you're going to keep the first fraction. Change to multiplication, and then flip the second fraction. Take the reciprocal of it. All right, now once you've done that, you're going to work on factoring these things. And this is a trinomial, and there's nothing in common, so it's probably 2 binomials. And when you look at it and you think about it, it needs to be 2 and 7 with them both positive. Okay. All right, then I might jump down to this one because it's also pretty easy to factor. I would use z and z, and then 8 and 2, both positive. Okay, now here's another trinomial with nothing common. So I'm going to factor it using a z and a z. And you notice how we got like 8s and 2s down here? We're going to need an 8 and a 2 here as well, with the 8 being positive and the 2 negative. And take the time you need to get these correctly factored. That's pretty important. All right, then the one in the denominator actually isn't a trinomial. See how it has a common factor? People mess this up because they start by writing 2 parentheses. But really, don't forget, factor out the GCF, right? Got to remember to do that when you have a GCF. So when you take out the GCF, you only have a z plus 7 left. All right, so basically what you got now is all of these have been factored. So you have their factored forms, and this is one big fat fraction with multiplication everywhere. So what we're going to do is we're going to come in here and we're going to cancel out the z plus 2's. Going to cancel out the z plus 7's. Here's a z plus 8 on the top and the bottom. And then we're going to look and see what we have left. And all I see left is a z plus 2 on top and a z on the bottom. I said z plus 2. I see a z minus 2 on top, and a z on the bottom. And those z's can't be canceled because that z on top is not a factor. That's not multiplication. So this is your final answer. Okay. All right. So in addition to those, I wanted to look at a couple more complex fractions. So I'm going to go to skip the adding and subtracting for now. And I wanted to look at a couple of the complex fractions. I want to look at number 14. It was 4 over y over 6 over y plus 6. I'm going to emphasize that main fraction bar. Okay. So there's really two methods you can use to solve this. I'm going to use the method I showed you earlier. This is the one where you use the least common denominator to clear the fractions. Works good on this one. Okay. So you have to look for the LCD. So you have to pay attention to these little fractions. And you see you have a y, and then you have a y plus 6. Okay. The LCD would be the product of those two. So what I'm going to do is multiply on top, and I'm going to multiply on the bottom by the same thing. That makes it mathematically okay to do. And then I'm going to look for the common factors. So here's a y and there's a y. Here's a y plus 6 I can knock out of there. And so what happens is, relative to that main fraction bar we had, I see a 4 and a y plus 6 on top. And I see a 6 and a y on the bottom. All right. Now, at this point, I take one more look at it, and I notice that, you know what, that 4 and that 6 in the denominator out in front, those are both divisible by 2. So I'll divide by 2. And my final answer on this one will be 2 times the y plus 6 over 3y. Okay. And then if you wrote it as 2y plus 12 over 3y, that's also okay. Okay. It's whether it's in the factored form or whether it's completely multiplied out. Okay. All right, there's another method I want to show you because you might see it in View an Example, and it really does work very well on this one. When you have one fraction divided by one fraction like we have here. Something you might like to consider doing is this. This just means division. So you could rewrite the problem as 4y divided by 6 over y plus 6. Then you could keep, change to multiplication, and flip. Okay. And then at that point, you could think of this as just one big fraction bar, and you could notice that you could divide by 2, divide 2 into 4 and into 6, and get your final answer. 2 over y, 2 times y plus 6, over the 3y. Okay. All right, so that works good because it was one fraction divided by one fraction. Okay. Let's do one more problem from this sheet. Okay. And the one I'm going to look at is number 15. So with number 15, the first method works really well where you use the LCD to clear the fractions. Okay. So this is number 15. It's 4 plus the 2 over x, all divided by x over 3 plus 1/6. Okay. So it's a complex fraction. The directions would still say simplify. So you'd have to think about your LCD. It's got to be whatever it would take to cancel out all of these denominators. So definitely need an x. And then a lot of people think 3, but 3 wouldn't cancel the 6 out. If you multiplied by 3 here, it wouldn't be big enough. You really need to use 6x. Okay. Now what you're going to do is you're going to multiply the entire numerator and the entire denominator by 6x. Okay. So that 6x gets distributed to these. All right, so it's important, I think, when you're first learning this especially, to write that 6x next to each of these. There'll be 4 spots when it gets distributed. Okay. So you're going to have the 6x times the 4 plus the 6x times the 2 over x, and then 6x times x over 3 plus 6x times 1 over 6. Okay. So what we're going to do is we're going to work on simplifying these 4 spots right here. And when we do, we shouldn't have any little fractions left, just that main big fraction bar right here. Now 6x times 4, there's no fraction there. They're both on the same level. That's just 24x. But 6x times 2 divided by x, this x cancels that x out. And you just get plus 12. See, this x is really on top and this x is on the bottom relative to the little fraction. Okay, here's the little fraction bar. This x is really on top with that x, but this 3 can go into the 6 twice. So we have a 2, an x times an x left. That's 2x squared. Okay, and then for this last little spot, the 6 cancels out that 6 because that's 6 divided by 6. And so you just have plus x. So what we've done is we've cleared all the little fractions. And now all we're going to do is try to simplify. So we notice that 24x plus 12 can be factored. We can take a 12 out. And that means we'd have so this is where I'm factoring that top part. 12, we'd have a 2x here, and you need this 1, so that 12 has something to get distributed to make the 12 happen. Similarly, on the bottom, x is common. And what we have left is a 2x plus 1 again. We need that 1, so the x gets distributed to that. All right, then this 2x plus 1 cancels that 2x plus 1 out. And basically, your answer is right there in front of you. It's 12 divided by x, 12 over x, and that would be your answer. Okay. So that's as far as I got in class today, and it's a good stopping point. We'll work on adding and subtracting next time, but I've gone ahead and opened up some homework, so go ahead and get started on that. All right, so let me stop this so it doesn't get too long, and we'll start back up on Wednesday.